Section 8 Electric Motors. AC motors are what we called also as the alternative current motors. So these sections apply the energy efficiency requirements for electric motors in buildings. So the general purpose of this is the T-frame, the single speed, the foot-mounted, polyphase induction motor of a design A and B configuration. So this is rated for continuous operation and operation at 230 to 480 volts, and it also has 60 Hz as defined in the North American or NEMA standard MG1, and weighs from 1 to 2 horsepower, drip proof and totally enclosed, fan-cooled enclosures, and shall be covered by the efficiency of the requirements under these guidelines. So the motor performance is exceeding to the nominal full load of efficiency levels given in the table. So the motor is operating more than 50 hours a year. So per year there is also a 70 hours shall be energy efficient types as shown, that will be shown in the table. So there will be a minimum type of IE2. It calls International Efficiency High. So these energy efficient motors are higher quality with increased reliability, providing saving from this reduced downtime, replacement, operation and maintenance cost. So the AC motors is not also rated full load efficiency and full load power, but also it is included in the information required by the latest edition of the Philippine Electrical Code Part 1, and it is one of the methods for determining the losses and efficiency of the three-phase cage induction motors. So the first cage induction the first phase of the cage induction motors is the motor selection. So this is the type or the size and the squirrel cage, the induction. The motor shall be selected only after an accurate or determination of the starting and running requirements of the load that has been made. So it is taking an account of the following factors. First, it is the maximum overload expected. Next is the ambient conditions. Next is the power supply condition, the future expansion, the deterioration of the driven load, duty cycle, and lastly the speed of the motor. So the next phase of the motor is the 5 factors above shall be considered carefully, as this motor suggests the selection of larger capacity motors compared with the use of low power factor and low efficiency of the motor. The third phase of the cage induction motor is the cases where the higher kilowatts is necessary due to special requirements of the application. So the motor rating may be increased but shall not exceed into 125% of the calculated maximum load to be served. So if this rating is not available, then the next higher rating may be selected. So in the AC motor, there is a what we called as the table of the minimum acceptable full load efficiency. So each motor size has different RPM, or what we call revolution per minute. So this table represents the RPM, or the running time, or the how many turns in how many turns will be counted per minute. So depends on the motor size. of the AC motor. Like for example, the 0.8 kilowatts or 1 horsepower motor size has an open drip proof motor. So there, if the revolution per minute is 1200, so the equivalent of its revolution is 72.0. So if the revolution per minute is 1800 and the motor size is 0.8, so the revolution per minute of its motor is 77.0. And if the maximum revolution per minute is 3600, then the equivalent of its 0.8 kilowatts or 1 horsepower in the motor size is 80.0. So it depends on the motor size. It also depends on how many revolution per minute has been done. So when the application requires varying output operation of motor driving equipment, for any application, a variable speed shall be utilized instead of electromechanical devices. So what we call is switch reluctance motor. So this switch motors or reluctance motors represent the several advantages, such as this is high efficiency, it has a maximum operating speed, there is a good performance in terms of torques, inertia ratio, or making them an attractive solution to a variable speed application. So their performing strongly depends on the applied controls. So next is the switch reluctance, because there are two kinds of switch reluctance motors. So this one also is it is also usually designed to operate at various speeds with the highest efficiency. So they are used mainly in domestic appliances like vacuums, like our washing machines, like in all kuan siya, can be used as our daily use for working in our house. So however, this can be utilized by power drive for electrical vehicles. So next is the high efficiency motors. So high efficiency motors are basically the flux density, then the low core loss and the low current density motors, which shall be employed whenever it is applicable. So there are minimum efficiency required, or what we call as MEPR. So for electrical motor use in residential, commercial, and institutional application in these guidelines, it shall be at least IE2 or whatever minimum energy performance required in the mandated by the DOE. So the goals of implementing MEPR is to increase the energy efficiency, promote energy saving, and reduce operating cost for electrical motors. So there are exceptions from MEPR. So these are the following: the submersible motor, so katong dun sila kadong like what we called as submersible, like can be used underwater. Next is the motors that are integrated into system that prevents the individual motor efficiency from being tested. So kuan siya mura siya inverter nga like mo protect sa siya, like mura siya transformer kaya niyang mura siya fuse nga kaya niya i-trip, like one of the use na sa motors. So next is the motors designed operated extremely high or low temperature in explosive environments like altitudes above 1,000 meters above sea level. So this is like sa taas na. So the latest version of IEEC is the standard electric motor. So these guidelines, on the other hand, the alternating current, or what we call as AC, or there is also a DC, a direct current, shall be also reference standard use in the guidelines. So that two kinds of turning current, the direct current and the alternating current, shall just only be used in any kind of procedure. So for the cooling system, so the using motor is the for for the minimum energy performance shall be required to a refrigerating and air conditioning and system as mandated by DOE. So there should be a guidelines, a procedure, how many like how many horsepower or any kinds of kilowatts can be used. There's a rules and regulation that can be mandated by DOE. So next is the starting and control method of electrical motors. The starting, so there is what we call is direct online. It is the most basic and the simplest thing starting method, although starting time is short but the torque at starting is smaller, the challenge, and the current is large, so it is suitable for starting small capacity motor only. So next is this star delta. So this star delta method has the three-phase induction motor whose stator winding is stipulated to link in delta connection. Next is the auto transformer auto transformer. So this refers to the reduction of grid voltage to the motor stator winding until the speed approaches to steady value. So this device shall be avoided unless extremely necessary. Because the motor is connected to the power grid, transformer tapping is chosen to receive required starting voltage and starting torque. And the last is the soft starting method. So one of the most important features that is electronic circuit is conducted into silicon control. So the soft starter is a voltage regulator that only changes the voltage without alternating the frequency at starting. Next is the variable speed or the frequency drives. So the variable speed drives is control the speed of machinery, changing the frequency of the motor that is being operated. Next is the VSD or the variable frequency drive. VSD is the variable speed drive, or the VFD is the variable frequency drive. So there are lots of motor that benefits from this, because this operation is a smooth starting, smooth acceleration and deceleration time, stopping method and reversal of motor factor, and a huge saving time if properly applied. So next is the throttling control of fans is easily done by the use of VFD, resulting to substantial energy reduction. So next is the foremost operation buildings shall be equipped by servo motors or VFD driven motors. So all motors of mechanical equipment over 5 kilowatts shall be utilized high efficiency motors at least 2 IE2 in accordance with the table given, coupled with variable speed drives. So all motors of cooling towers shall utilize high efficiency motors that has a speed application or soft starter. So these kitchen ventilation fans are exempt for these requirements. So non-centralized air conditioning system. However, buildings are not required to employ variable speed controllers. That the fan or air conditioning system shall comply with the MEPP or the though mandated. So the next is the DC motor, or the direct current motor. So these DC motors is the high starting torque, a quick starting and stopping reversing. So differ siya sa AC motors. So it has a variable speed with voltage free from harmonics. So the DC motor principle are used in tools, toys, and appliances. So the universal motors are lighted brush motor with the portable power tools and other application. So brushes like DC motors produce comparatively low operating noise. It also has a long battery life while batteries are needed. So unless extremely necessary, use large DC motors so that you can have light when there's a blackout. So direct current motors with inverter or DC drives. So it is strengthened the advantage of DC motors losses from electromechanical components are replaced with low static components. So the DC motors and the other inverter driven DC motors are performed over other AC motors controlled by electromechanical devices. So efficiency further enhanced in multiple DC operation using common DC drive cost saving are possible because only one larger system is only for many smaller reactor braking units contactors. So due to its low energy consumption and very good speeding control capabilities, DC motors with inverter drive are used now in many applications such as inverter type, air conditions, inverter type of refrigerators. Like now, we have inverter, air conditioning, inverter refrigerators. So, above all, the methods of this DC is the provision of proper sizing, control the components, and protective device shall be observed. So the pump. Next is pump. A pump nameplate shall cover all electrical parameters, mechanical information to ensure that the sanction is discharge dimensions applied for the maximum performance. It is also has a proper size of the application to attain the flow near peak efficiency retaining between the flow between 80% and 100%. So the pump shall be properly put, and if not, the size of the pump is improperly sized, operated too far of the BEP, so there is an imbalance resulting to the parts fail due to excessive wear. So this creation imbalance pressure increase the radial loads on the impeller and would cause shaft deflection. So the application requires output operation to motor-driven equipment such as centrifugal pump where a variable frequency speed drive shall be instead of throttling the output of the pump. Next is the escalators and walkways. So the escalator is moving a ramp or walkway shall be fitted with the automated control to reduce to slower speed when no activity has been detected for a maximum period of 1.5 minutes. So there will be a duration or maybe adjusted depending on the demand. So escalators and other moving ramps or walkways shall be automatically be placed on standby mode when there is no activity been detected. So the escalator has the high gravitational potential energy. So it shall be equipped with the VFDS or occupied with line regenerative drives. So next is the elevators or the lift. So the lift is shall be used as AC. So variable voltage and variable frequencies or VVVF drives on the hydraulic elevator to reduce energy demand. So the elevator shall of buildings with at least 10 stories, especially office and buildings, hotels, shall be equipped with VFDS. So The elevator shall be used energy efficient lighting, including the display of the elevator. Car shall be a high average lamp efficiency. So, all lighting except the emergency light powered by the UPS of the building shall switch off after the elevator has been inactive for a maximum period of 5 minutes. So, that's it for elevators or lift. Next is the required design documentation. So, the following documentation shall be required for the building permit application. So the architecture floor plans showing the location of the elevator. You can see the blueprint, moving and ramps, walkways and pumps. So section showing the height and the vertical location of the elevator. So the electrical plan shows the single line diagram of the power supply manual and automatic control circuit load schedule and the technical specification like legends. So the mechanical equipment schedule showing the description of the operation of the elevators. The technical data sheets like brochures of VFDS like VSDS or the regenerative drive equipment elevators, escalators or any other moving ramps or walkways and pumps. So the process control diagrams of elevators and escalators and moving pumps is relevant drawings and plans. So that's all in the section 8 electric motors. Thank you.